Good morning, dear science class friends. Today we are discussing our second part of this chapter. Our chapter name is acid, bases, and salts. So it is our fifth chapter, and I hope you are enjoying with this online studies. Okay, and you are understanding this all these things. Okay, acids, bases, and salts. So today we are discussing our activity 5.1, that is on page number A56. So aim to observe the chemical nature of acetic acid. So acetic acids, you know about the formula of this acetic acid, that is acetic acid, that is the formula is CH3COOH. Okay, this is the acetic acid. Okay, to observe the chemical nature of acetic acid, to observe the chemical nature of acetic acids. Requirement: a glass jar, a white vinegar, a crushed eggshell. So this we have to need. Procedure: place a few pieces of crushed eggshell. Okay, eggshells we need in a glass jar. Pour some vinegar on these pieces. Bring a lighted matchstick near the mouth of the jar. What do you observe? Okay, so in glass jar we have to cap some eggshells and some vinegar, and then we have to make a lighted matchsticks on that. What do you observe? As soon as vinegar is poured in the shells, a few bubbles are seen to escape. The eggshells disappear after some time. Okay, so eggshells just disappear in this vinegar because the lighted matchstick. Okay, the lighted matchsticks get extinguished. Extinguished means bujh jana. Okay. So what is the explanation on behalf there? Okay, I hope you are understanding what is this. A glass jar we have to take. We have to pour the eggshells in the crust forms, and then we have to add some this vinegar. Vinegar means this acetic acid, CH3COH, and after that we have to see the eggshell is just disappear from the vinegar, and when the lighted matchsticks on that, they are the extinguishes. Extinguish means bujh gaya. Okay. Explanations: the chemical present in vinegar is acetic acid. Eggshell is made up of calcium carbonate, means CaCO3, that is the salt. The reaction between the acetic acid and calcium carbonate produces an carbon dioxide gas, a colorless organic salt and water. So when the a reaction is formed in between the calcium carbonate and acetic acid, then formation of CO2, salts and water. Carbon dioxide does not support burning and therefore extinguishes lighter matchstick. So the evolution of this carbon dioxide does not support the this lighting. Okay, it does not support the it means the flame. Okay, so that's why they are just extinguishes. The gas escapes are as bubbles, and the organic salts form dissolve in water. So no residue is left after the reaction. So therefore the eggshell seems to be a disappear. So after that, because due to the reaction in between the acetic acids, okay, and the eggshells, which is the calcium carbonate, so they are just disappear in from that. Now here it is some one table of strong and weak acids and some bases, and which is presented. Okay, so like carbonic acid, fizzy drinks. Okay, in the drinks this carbonate water is there. So carbonic acid, that's the weak acids, and sometimes we have to edible also. Okay. Hydrochloric acid means HCl, strong acids, generally digestive juice in the stomach. Okay, due to that our digestion can be possible. Sulfuric acid, that is the strong acids and used in the car batteries, anti-rust paint, used for making fertilizers. Okay. Nitric acid, that is the HNO3, strong acids. Okay. Mineral acids also used for making fertilizers. Okay, like in NPK. Okay. Phosphoric acid, strong acid, used for making fertilizers and explosives. Okay, H3PO4, that is the phosphoric acid. Now some of the commonly used substances contain the following bases. Bases means magnesium hydroxide, milk of magnesia, used in the form of ENO, okay, and diazine and gasofast or like that. Ammonium hydroxide, that is the window cleaner. This is the ammonium hydroxide. Okay. Calcium hydroxide, that is the lime water. Sodium hydroxide means NaOH or KOH, that is the potassium hydroxide, used in the preparation or manufacture of soap. Okay. Now the indicators. Indicators means indicators are the things which can indicate the either the substance is acids or maybe the base. Okay, so this is known as the indicators simply, or sometimes we have to tell that is the acid base indicators. Acid base indicators. So what is this? Look, when we want to test whether a substance is an acid or base, we do not always taste it or touch it. It means if any substance contains the acids or bases, every time we cannot notice with the touching or with the help of this to taste. Sometimes we have to use some other things to test it. Okay, and bases are quite strong and corrosive. They may burn or damage our skin permanently when they are touched or tested. Therefore, we use some special substance to test them. These substances indicate whether a substance is an acid, base or neutral substance by a change in their color. They are known as the indicators: turmeric, litmus, china rose petals, goodal, purple cabbage juice are some of the naturally occurring indicators. Phenolphthalein and methyl orange are some synthetic indicators. Okay, phenolphthalein and methyl orange are some of synthetic indicators. Now the litmus is a natural dye. Okay, so this litmus is the first indicator we are just introducing here. What is this? It is a natural dye extracted from the lichens. Actually, lichens is a symbiosis of algae and fungi. We will study in the next few coming classes in the 9th class. Lichen is a symbiosis of algae and fungi, in which algae do the photosynthesis for that and fungi gives the shelters to them. Okay, and for water minerals also. So these both are beneficial to each other and both are living simultaneously and both are making one form of organisms. So that's why litmus can be extracted from the lichens. And it is a purple or mauve in color and distilled water. It turns red in the acidic solution and blue in the basic solution. Okay, so generally with the help of litmus we can test either any substance is acids or bases. And for that, if the substance changes blue to red, then that is acids. And if the substance changes red to blue, then it will be the base. Okay. It is used as a solution or as a strip of litmus paper. Sometimes we have to use in the form of solution or sometimes in the form of strip of paper. Litmus paper is made by soaking a blotting paper in litmus solution and drying it. It is available in two colors, red and blue, known as red litmus paper and blue litmus paper. Acid or their solution change the color of blue litmus to red, while bases or their solution change the color of red litmus to blue. I already told about that. Neutral solution do not change the color of red or blue litmus. Okay, it means for the neutral solution there is a no change of color, and okay, there is a no change in the color of red or blue litmus. Now the turmeric, haldi जो आप घरों में use करते देखिए, it is also used as a natural indicator, which is a yellow in color. It is made by coloring a blotting paper with the turmeric paste and then drying it. Sometimes we have to use this blotting paper, and it is also a make a wet paste of this turmeric, and then this blotting paper also changes into the yellow color. Turmeric powder mixes with the little water forms turmeric paste. In a basic solution, these indicators changes to red, but in acidic solution, its colors does not change. So turmeric powder mixed with a little water forms a turmeric paste. Okay, we have to make a turmeric paste, wet turmeric paste. In a basic solution, this indicator changes to red, but in acidic solution the colors does not change, and you have to prove it, because you have to see that in the white cloth, if there is any stain of our vegetables or which contains the turmeric, then there is a yellow type of stains on that. Yellow type of this stain is that, and this yellow type of stain just changes when we are rubbing the soap, then it can be a changes into the red in color. So the yellow stain can be changes into a red in color with the help of base, but this can be a not change. There will be a no change with the help of acids or with the acids. And so, which is a basic substance, when rubbed on a wet turmeric stain turns red. If a turmeric paper is dipped in a vinegar or lemon juice, its color remains the same. Okay. So turmeric is an indicator for testing bases only. Only for bases we have to use the turmeric. Turmeric indicator does not change its color even in a neutral solution. So you have to see here, there is a no change in the turmeric with the acids and with the neutral solution, but you have to see there is a change with the base, and its colors will be changed from the yellow to red with the base only for the turmeric. And we already discussed in the previous one, that is the litmus one. And litmus one, for you can use that with the acids the blues changes to red, and the bases for they are changes to red to blue. Okay, 1 minute, I will take one chalk. Okay, for that. Okay, this. Now the China rose. Now the China rose. It is prepared by placing a few China rose, that is the goodal, and you already seen a red color, a big flower. Okay, you seen anywhere. Okay, so petals in a beaker of warm water. We have to use these petals in a warm water of beaker until the water becomes colored. This light pink or light red color water is used as an indicator. So this light pink or light red color water used indicator. China rose indicator changes to dark pink. Okay, it means the magenta color. In acidic solution, it means, okay. So you have to see that with the China rose, it is important, and it is you have to hear that dark pink, with acids, and green color, green with bases. So this is the natural indicator. China rose flower, it means golden flower. Petals just make in the it means the deep into the warm water, and after that, if there is any substance is acid, then it gives the dark pink color, and if any substance is bases, then it will give the green color. Okay, so this is the China rose indicator. Therefore, it is an indicator to acid as well as bases. Now the purple cabbage juice, purple type of cabbage, it means purple color cabbage, we have to use for that. It acts as an indicator for both acids and bases. It changes from purple to red. Okay, purple cabbage, purple cabbage, purple cabbage, purple to red, purple to red, purple to red, purple to red with acid. And green color. Okay, it means changes to green color. Okay, it means from purple to green base. Purple to green base. So this is okay. So purple cabbage juice, purple to red changes with the acids, and purple to green with the base. Red cabbage juice, violets, prime roses, cherries, beetroots, grape juice, and any flower or parts of plant with the red, blue, or purple color contains chemicals that act as a indicator. So some more examples here to explain either any substance is acid or base. For that we have to use that litmus. So for that we have to use that indicators in the form of indicators. Now the other indicators, and these are the synthetic and artificial indicators which can be prepared by the human beings or man-made indicators. That is the phenolphthalein. It is used in an acid-base reactions, neutralization reaction, phenolphthalein. Okay, so this is the one indicator is there, and to indicate the completions of the reactions by color change. In a basic solution, phenolphthalein gives a pink color, and in an acidic and neutral solution it remains colorless. Okay, so what is the color given by the phenolphthalein? Okay, what is the color to give by the phenolphthalein? So with the help of phenolphthalein, it gives the colors like, and with the methyl orange it changes the yellow color. It changes the yellow color in neutral and basic solution. In neutral and basic solutions, it indicates an acid solution by changing to a red color. The effect of a few indicators on a dilute solution of some commonly used laboratory reagent are given in the tabular form. So we have to write for the phenolphthalein, and so what is the color with the phenolphthalein? Phenolphthalein. Yeah, phenolphthalein, and with the color of with the methyl orange. Okay, with the methyl orange. Okay, so what is the color given by that? With the acids and with the base. Okay, so with the acids, look that the color of pink to colorless. It means with the acids, pink to colorless, colorless. Okay, and with the acids. Okay, and with the base, there is a pink to colorless. Sorry. Solution colorless to pink. Pink to colorless means acids, okay, and colorless to pink means and this is for colorless to pink, okay, it's colorless to pink. And for methyl orange, look, it change yellow color in neutral or basic solutions. So orange to yellow with bases, okay, with the bases, and it indicates the acidic solution by changing its red color. So orange to red, okay. So look, some table is given here, a few examples of some substance. It's a maybe neutral solution, it's maybe acidic solution, and maybe there is a basic solution. So what are the color changes? Like dilute HCl, you know about that. This is the HCl, it is the acids. So from the litmus it changes blue to red. Turmeric paper, it means turmeric, no change, because there is a no change color of with the acids. For the only basis for the color, there the red will color will change, okay. And light pink to dark pink, pink to colorless, and acidic, okay. And I already wrote for that. Phenolphthalein, there is a color I already wrote. Methyl orange already wrote. Purple cabbage also already wrote. China rose already. And for litmus, you have to hear the name. And for the turmeric, okay. No change with acids and red with base, and for the litmus there is a, for acids changes blue to red, and for bases red to blue. So on the behalf of that, you have to make this, and you have to understand this table. Like dilute sulfuric acid, same as it is, like the HCl. For dilute nitric acid, same things. Acetic acid, same things. Now the sodium hydroxide, that is the base. Red to blue with the litmus paper. Effect on turmeric paper, yellow to red, okay. And light pink to green, okay. And colorless to pink with the phenolphthalein, and basic, the solution is basic. Same ammonium hydroxide is the basic solution, calcium hydroxide also basic solution. Aerated drink and soda water, this shows the carbonic acid, so this shows according to acids. Detergent solution, which shows the basic solution, so according to bases they have to indicate. Soap solution also according to bases. Common salts no change, because common salt is the salt and they are having the neutral solution, so no change with red litmus blue, no change of color with the turmeric paper, no change with the color of China rose indicator, no change with the phenolphthalein, and no change with a neutral showing. Shampoo red to blue because basic solution, and baking soda red to blue because basic solution, baking soda also red to blue, okay. Milk of magnesia red to blue, lime water red to blue, and washing soda red to blue. So these all are having the same type of characteristics like a basic solution, and same type of indication with the basic or red with their particular indicator, okay. All the above substances are tested either in the solution or with the most indicator. This is because the acidic or basic properties of the substances are observed only in the presence of water. So when the solution of these substances are made in water. So when the solution of these substances are made in water, okay. So these are the properties of things. In next class, we will study about the activity of 5.2 and pH scale and universal indicator. So I hope you all are this understanding with the basic solution, with the acidic solution, with the neutral solution. You can see all these things are the same. Okay. So it means what are the different characteristics showing by their properties. Okay. So thank you. Next study we will do in our next video class.